To start off, the tape will be dropped at a height of 28.9 cm, which is by the table H. And the time recorded for the tape to drop at that height for the first lap is 0.19 second, the second lap being 0.16 second, and the third lap being 0.18 second, and now trying at a higher height. Now at this higher height, the tape would be dropped at a height of 56.4 cm, which is by the mirror frame. And the time taken for the tape to drop at this height for the fourth lap would be 0.24 seconds. For the fifth lap, it would be 0.25 seconds. And for the sixth, it will be 0.22 seconds.
To start off, let's address the physics principle behind freefall. While looking at linear motion, acceleration is the rate of change in velocity with time, meaning that it is dependent on speed and time of the object. During the freefall on Earth, all objects should fall at a constant rate of acceleration because of Earth's gravitational pull. By using the formula for acceleration, a equals to v minus u divided by t, we can determine the acceleration of freefall on Earth, and the SI unit of acceleration is meter per square second. By looking at the previous slide, we all know that all objects should fall at a constant acceleration on Earth during freefall. Thus, we can do an experiment to see if this statement is true and to determine the magnitude of the acceleration. By using a double-sided tape as a test object, as shown in the video, we dropped it at different height, which would still grant us the same acceleration. We measure the distance from which the tape is dropped and measure the time, which is how long the tape would take to drop. We can use the dt formula to find out the speed of the tape, and then followed by using the acceleration formula, which is a equals to v minus u divided by t, which can be helped to find the acceleration during freefall. This is the experimental setup that is used in the video. The apple shown here is just a placeholder for the double-sided tape used in the actual experiment. To start off, the object, the apple, or rather the double-sided tape used in the experiment, is stationary, meaning that its initial speed is 0 meters per second. A stopwatch is used to track how long the object hits the ground, and by using the distance from which the object is being dropped, we can use the formula for speed, d over t, to calculate the speed of the object. The video experiment shows 6 laps being taken down, and is put nicely into a table form here. The acceleration of all 6 laps are all different, and the average acceleration of all 6 are about 9.78 meters per second square. The average acceleration calculated in the previous slide is about 9.78 meters per second square, which is just a little less than the actual value, which is 9.8 meters per second square. This can be due to 2 errors, one of it human error and the other is the air resistance acting on the object.